When people think of GPU mods, a few things come to mind. Usually they're performance mods that are just aesthetic. So for instance, adding a bunch of heatsinks to the back of your 3090 so you can mine Ethereum with it for weeks at a time. Or strapping fans onto other parts because your OEM didn't do a good job of designing a cooler. However, there are other even more serious mods like doing shunt modding or things to overclock that could actually potentially physically ruin your entire GPU. But today I came across a mod that harkens back to my days as a teenager on overclock.net, and it has everything to do with AI. And it comes from the infamous George Hotz of the TinyCorp, which is the creator of TinyGrad and the TinyBox, which now doesn't only offer AMD GPUs, but also offers NVIDIA GPUs. And they had a wild breakthrough that they just gave away to everyone that's completely insane. So we're gonna have to get into a bit of the weeds here technically, because what this enables is something that's a little bit complex and that a lot of you might not know about unless you've been digging into Linux and GPUs and slamming your head against a desk trying to get all those drivers to work as fast as possible. So what George released with the TinyCorp is P2P support for 4090's by modifying an NVIDIA driver. And of course, this works with TinyGrad and NCCL or Torch, which is insane because basically this means that you can get all of the features you would otherwise have to buy NVIDIA's workstation GPUs for on consumer level 4090's. And this is basically the only distinction between the RTX 4090 and something like an RTX A6000 or A8000, except the A8000 has a bit more RAM. So why is this mod such a big deal? How did this come about? Have we seen anything like this before? And what does it mean for you if you own a 4090? Welcome to AI Flux. Let's get into it. So P2P support is interesting, and it's directly intertwined with kind of the purpose of the TinyBox. So it's not surprising that TinyML or TinyCorp actually ended up running into or coming across this solution. So for those of you who don't know, the whole purpose of the TinyBox was for around $16,000 to give you around 1.7x the performance of the equivalent GPUs that would be workstation grade. And roughly this was meant to be a single box that you could run a 70 billion parameter FP16 model, so at full precision, with around 140 gigs of VRAM. So the idea was giving you as much power as possible in as small a box as possible, hence the term tiny box. And this path hasn't been easy. For instance, initially they wanted to go with AMD GPUs because their price point was better and their drivers in theory were more open. But obviously there's been a lot of spat between George and the CEO of AMD over just how bad their drivers are. There's been some progress there as well with internal development from TinyCorp. But this development today is crazy because what it means is that you get a feature called P2P, memory transfer. So for those of you who don't know, consumer GPUs talk differently to the motherboard they're plugged into than workstation grade NVIDIA GPUs like, the A6000, A100, L40, etc. And even more different than the DGX modules that use the SXM2, 3, or 4 interface with nVSwitch. Basically, what this means is, so for those of you who don't know, NVIDIA consumer drivers have to go through system RAM to talk to the rest of the system. So for instance, if I had two GPUs that were just 4090's before today, with a official NVIDIA driver, I would have to actually shove data into system RAM, which would then be pushed into another GPU, which is pretty slow and actually stresses the CPU a lot, which is why sometimes if you guys have used really big VPSs and you look at the difference in CPU usage between a DGX or a PCI-based system, even with the same spec of GPU, you'll notice that on the PCI cards, there's way more CPU usage, and especially if it's 4090's. If you compare 4090's to even like an A8000, it's a striking difference. So what's great with P2P is it means that you can actually just skip all that. It means that you can actually send data from one GPU to another right over the bus. And what's cool is this works for the same reason that we no longer actually see NVLink tabs on any GPUs. And it's why SLI bridges are kind of an ancient pastime of NVIDIA GPUs, even if you thought those are fun to use in high school like I did. And what's interesting is this isn't the first AI GPU mod we've seen. I'm gonna tease a video real quick of something that I'm reviewing and that I'm actually gonna try on my own, which is a physical hardware mod to up the RAM to 22 gigs in a 2080 Ti, which is kind of cool. And then also what this reminded me the most of was when someone figured out in 2013 that you could actually change resistor values up on the back of a GTX 6090, which actually had two GPUs, and you could actually trick the official NVIDIA driver into thinking it was actually a Quadro K5000 and a Tesla K10, which at the time were GPUs that cost over $3,000 to $4,000 each. But nonetheless, software mods like this, I think, are the coolest because they immediately unlock immense amounts of performance, and you don't have to do anything. You don't have to get a soldering iron out. You don't have to start ripping apart your expensive GPUs. And my girlfriend won't get even more mad at me that I've spent more money than my car in a GPU server. But anyway, so I'm excited to try this out on my 4x4090 machine. And I've had friends that have already used this driver on a 6x4090 machine. But how did TinyCorp actually figure this out? So obviously, I'm not going to get too far into the weeds since I'm a software engineer and a lot of you might not be as technical. But what's interesting is there's actually a pretty great write-up of how they came across this. So they say here that normally P2P on NVIDIA cards uses mailbox P2P, which is basically a protocol developed by NVIDIA that talks between GPUs directly, allowing them to dump GPU RAM into another GPU without actually going through system RAM. There is some hardware interface designed to allow GPUs to transfer memory back in the days of small bar. It's not present or disabled in hardware on the 4090s, and that's why P2P doesn't work. And what's interesting is with software stuff like this, it never happens out of nowhere. They're usually kind of crumbs and little hints left along that then people are able to exploit. So in this case, what's interesting is there was actually a bug in really early versions of the driver that they used to find this advancement. And what's funny is there's a post that describes this entire thing on the NVIDIA developer forums, which, as many of you know, if you tried to install NVIDIA drivers on Linux, that sometimes you get great insights from these forums, and other times they're just entirely dead ends and completely full of useless information. And what's funny here is this person actually identified this all the way back in November of 2022. So with that quirk or a bug that turned out to actually be a really interesting solution, they actually reported that P2P, for some reason with this driver quirk, actually worked. And it was actually sending stuff over the PCIe bus. However, because the mailbox hardware wasn't present, think about this like nVenc, but for a special NVIDIA protocol that just sends data back and forth instead of video. These copies wouldn't go to the right place. So you could even crash your entire system by just sending zeros between GPUs. Now, what's interesting is in some 3090s and all 4090s, NVIDIA added large bar support, which is a lower level protocol that is only used for sending raw data between memory. And what's interesting is this is also present in H100s. So you can see here, if we look at, for instance, this 8102 or an RTX 4090, we see a lot of similar things that we would actually see in an H100. You can see that bar 1 is size 32G, and in the H100 they also added support for a PCIe mode that uses bar directly instead of mailboxes, called bar 1 P2P. So someone just asked the question, why can't we turn that on in a 4090 if the hardware is already there to support this protocol? So they did this by bypassing something called Hall, which is sort of a way that NVIDIA cleverly blocks certain features in their consumer drivers. And it's completely different from what was done with the 6090, where the driver would look at certain resistor values and then decide what GPU it was looking at, since the resistor values were used to understand what GPU it was, and now that's actually done in kind of a secure enclave on the GPU itself. So the method they used here is really similar to KBus enabled static bar mapping 1, which just maps the entire VRAM into bar 1. This mostly works, but we had to disable the use of a certain region, and they're not really sure why, but at the end of the day, this works. And basically, it's just another way of representing VRAM to the GPU and the driver itself, which is integral to actually having this memory-to-memory transfer on GPUs work. And although this might seem like a simple fix, it's not entirely that easy. They ran into a number of roadblocks on the way. For instance, completely screwing up how the GPU actually is able to map its own RAM. So an MMU fault is relatively common if you've like overheated your GPU or used the wrong kind of riser. You've maybe seen this. And what's interesting is it actually has to do with how you're passing through certain parts of the CPU and how you actually set peer IDs, which is kind of interesting. And what's cool is after a little bit of messing around, they figured out that simple P2P actually works. But in certain cases, the copy doesn't happen. And the issue is understanding what the motherboard, what address the motherboard has actually given the GPUs. So the key is actually just keeping a place in memory where one GPU can actually know where the other GPU is and then going through there. And the relatively simple fix here was just understanding where the bar 1 base address was and then actually just writing them down in the right place for the GPU. And what's funny is a broken NVIDIA driver that unlocks more features is actually still more usable and stable than what is considered a production-ready driver from AMD, which is kind of hilarious. And with all this enabled, it totally works. Here's a basic test of what's going on. So you have GPU 1, you have GPU 0, GPU 1 on a CPU host, basically saying it's not a DGX host with NV switch. And then there's a custom kernel running on these GPUs, which then sets the bar addresses and lets them know that these are the addresses actually being used. And it's insanely fast. Right now, you can see here that in certain cases, you're getting 50 gigabytes per second of transfer in between GPUs, and it actually works with NCCL or Torch. And right here, TinyCorp is showing this running on 6 GPUs without any issues. And this is just completely nuts. And again here, the irony is people are saying, well, AMD must just be in complete disbelief because again, even with a massive head start, they've entirely lost to nVidia, even when using a broken driver bug to actually enable more features. And the funny thing is that I assume this is George responding, but he says AMD's driver is not stable. They had a chance to release firmware or documentation, and they have us try to fix it and stick exclusively with Tinybox Red. They didn't, which left us in a bad place, and as a result, they built an NVIDIA version that is probably about the same price and significantly more performant, which is kind of, again, a hilarious kind of L for AMD. And I do want to clarify here, Michael here asks a really great question, which is, do you think this could also enable Peer Direct, which is a way you can pipe data from a compatible NIC directly into GPU memory? And this is also cool because GPU Direct is another technology NVIDIA has released that allows you to write directly from a system SSD, like an NVMe SSD, right into VRAM on a GPU. This also means you can directly talk over a, say, 100 gig network bus to your GPU. So because it exposes all the VRAM on bar 1, so anything in the system, even on the PCIe bus, including NICs or NVMEs, should also be able to DMA to it. So what's interesting is this is kind of a quirk of the implementation of GPU Direct, and it's a question people have had for such a long time. And of course, Yassine is super excited, and by the way, you should check out Dingboard if you haven't already. So again, this is a wild advancement that's come out today. It's one of the coolest Fridays I've had in a while in terms of advancements, even aside from Meta and Intel releasing their own AI accelerators. Let me know if you plan to use this. In theory, this should also work on 3090's and potentially some other 4000 series GPUs from nVidia. It's a really welcome update given that we're probably going to have to wait a significant amount of time to get our hands on the 5090. And I'm excited to try this out, and if you'd like, I can also live stream me trying to do this on my 4x4090 system, and I also want to show that to you guys. I've gotten a lot of comments asking to see it. So are you going to use this on your GPUs? Do you think you might consider buying a TinyBox from TinyML or TinyCorp now? Let me know in the comments below. As always, I hope you learned something, and if you like this video, please like, subscribe, and share, as it helps us out a ton. And we'll see you in the next one.